Hello everyone. I'm going to introduce all of you to a Python shortcut called as Syntactic Sugar. Let's say that we have a variable x which is assigned a value of 10. I want to increment the value of the variable x by 1. There are two different ways for doing that. I can say x equal to x plus 1, which will now update the value of x to be 11. The second way is the syntactic sugar. I can simply say x plus equal to 1, which is the shortcut for saying x equal to x plus 1. X plus equal to 1 implies that you want to take the value in x, increase it by 1, and reassign the new value back to the variable x. So if I display x now, it's going to contain a value of 12. This shortcut will work for many mathematical operators. For example, I can say x minus equal to 1, which will decrement the value of x by 1. In the previous video, I gave you three different examples of bugs. The first one was phi equal to x. The second one was z equal to x plus capital Y, where variable capital Y is undefined. The third one was x uptick y, when we wanted to compute x to the power y. Let me define the three categories of bugs. Dog, cat, the, of, chase any. The sentence does not make any grammatical sense, correct? That is because it is word soup. Such errors are called syntax errors. Syntax errors never make sense to Python. Python is unable to execute even a single line of code if your program contains a syntax error. So syntax errors are non-starters. An example would be phi equal to x. This sentence is false. It is grammatical, but makes your head explode if you think about it. Well, I'm saying this sentence is false, so it must be true. Then why am I saying that this sentence is false? Such errors are runtime errors. Python needs to run your program to find out whether it contains a runtime error. Python will be able to execute all the lines of code which do not contain an error. As soon as it encounters the first line which contains an error, Python will crash. Examples of runtime errors would be type error, zero division error. 1 week is 10 days long. The sentence is both grammatical and coherent, but it is incorrect. Obviously, 1 week is 7 days long. Such errors are called semantic errors. Your program will run without producing any kind of an error, but the computation result will be incorrect. An example of semantic error would be area of square is equal to side of square into 2. Think about how you can fix this particular semantic error here. What do you think is the worst kind of error? Please pause the lecture video here and answer both this question and the previous question about how to fix the semantic error. A lot of students think that semantic error is the scariest of them all. That is because your program will run without running into any kind of an error and produce some output. That particular output will be an incorrect result. So it will require you a lot of debugging to figure out what exactly is wrong with your program. Next, I'm going to go through a couple of demo problems. Let me give you an outline of problem number 1. We have 4 different variables here, which are a, b, c, and d. All 4 of those variables contain integer values. The question here is asking, what is the sum of all the odd values? The simplest answer for this question would be to say that sum is equal to a plus c here, correct? So let me copy these lines of code and paste it into Python tutor. And I'm going to define a total variable and I'll be assigning a plus c to it. Let me print the total variable so that we can take a look at the output in the output box. So what is wrong with this simple solution here? What if I change the value inside the variable d to be 7? Then your solution here does not work anymore, correct? So the problem here is that you've hard coded the solution. What exactly is hard coding? You're defining the total in terms of two variables here, which are a and c, without checking any aspect about the value contained inside all of the variables, correct? So let me introduce to you a mathematical trick for enabling you to solve this particular problem. So I'm going to compute a mod 2 here. Recall that the modulo operator enables us to compute remainder when we divide a by 2. A contains a value of 3. So 3 mod 2 here is going to be 1, correct? Because when you divide 3 by 2, you get remainder as 1. What would be the result of b mod 2? That would be 0, because 4 when divided by 2 will give you 0 as the remainder. Similarly, c mod 2 will give you a value of 1 and d mod 2 will give you a value of 0, correct? What can we do with this trick? Let's say that I take the result of a mod 2 and multiply it by a. Notice that you're getting the result as 3 for this particular line. What if I take the same computation and replace the variable name a with b? When I compute b mod 2 and multiply that to b, I'm getting the result as 0. I'm sure you get the rest of the solution here, correct? So we can perform this computation on all of the variables here, and we can simply add the result of the computation together. So let me copy this particular computation, and I'm going to remove these two print statements, and I'm going to define total variable as this computation plus the repetition of computation on the variable b, and I'll be repeating that for variables c and d. Please be very careful whenever you copy paste code. You need to take really good care to update the variable names. It's such a head scratcher for you if you don't use the correct variable names when you paste code. So let's go through this code from the beginning. So I'm going to use these buttons down here. So I can click on first. So that will enable me to run the code in a line by line manner. So I can click on next here. So my suggestion for you is to come up with a mental model of execution of a particular program before you actually use Python tutor. You can use Python tutor to verify whether your understanding of that particular program is correct or not. So we are going to perform in order execution. So line 1 is going to get executed and you'll get a variable name a in your visualization here, which contains a value of 3. Similarly, when you execute the next few lines, you'll get the other variable names. When you compute total initially, you're going to get 8. And then after the second computation, also you'll get 8. Finally, you'll be printing total, which will go to the output box over here. So let's go through this problem with different test cases. It's obviously working for the current set of input because it's giving you the result as 8. 3 plus 5 is 8. The simplest test case for you to try here would be to change all the variables to contain a value of 0. That produces the output as 0 here, so that's good. What if I throw in an odd number? So we are getting 1 as the output, that's good. What if I change b to 2? That's still giving me 1, that's good. What if I change c to 5? That's giving me 6, which is perfect. And if I change d to 8, it is still giving me a 6. Looks like our program here is working. So it is essential for you to go through test cases which will enable you to test the corner cases of your program. Let's move on to the next demo. I'm going to skip over the float demo. We'll come back to this later. Let's go through the string demo. For this demo problem, we are going to keep track of scores of two players, Alice and Bob here. Alice has 10 points, Bob has 8 points. How are we going to keep track of scores? We are going to use vertical lines to represent one score point. The program is expected to output the name of the player followed by colon and followed by number of vertical lines which represent that particular player's score. So whenever you start writing a program, you need to think of good variable names. I can possibly use Alice and Bob here as variable names, but what if I wanted to play with other players? So really good variable names here would be player 1 and player 2. We need to keep track of multiple things here, correct? We need to keep track of the name of the player and also the score corresponding to the player. So think about how many variables you would need here. So you would require to have two variables to keep track of the names of the player and two variables to keep track of the scores of the players. So let me switch to Python tutor and I'm going to define player1 underscore name here. Since I don't want to keep typing this lengthy variable name, I'm going to shorten this to p1 underscore name. I would recommend you to use player1 underscore name because that's more descriptive. So let's say that I am assigning the value as Alice to p1 underscore name variable. Recall that you'll have to use double quotation for representing string value in Python. So I'm going to define p2 underscore name as Bob. Then I'm going to define p1 underscore score as 10 and p2 underscore score as 8 here. What do we want to do next? We want to be able to create such a display with vertical lines, correct? So let me first print p1 underscore name. And then what do I have to do to add a colon? Recall that you'll have to add a plus, which stands for concatenation operator. And then once you have the colon, you're going to have to type in the score, which is represented using vertical line. Do you have to type in 10 vertical lines here? Probably not. That will be considered as hard coding. So how can you take this one vertical line and replicate it 10 times? Recall that you can use the multiplication operator for that, and you can multiply a string with an integer, which will enable you to replicate that particular string that many number of times. So we have the display for Alice. Let's repeat that for Bob as well. So what's wrong with this particular display here? It's very difficult for you to compare Alice's score and Bob's score here, correct? That's because the name Alice and Bob has different number of characters inside it. Wouldn't it be nicer if you can line up the scores in a neat way so that you can very easily compare the scores and tell who the winner is? I'm going to introduce you to the length function. Let's first go through what exactly the length function will do. So I'm going to call the length function by saying len of, and I'm going to say p1 underscore name. You might have been able to guess that the len function counts the number of characters in a string. Next lecture, we are going to learn more about functions. For now, you just need to know how to use the len function. So len function enables you to compute the length of a given name. We need to create some sort of boundaries for the names here so that you can align up the scores together. So my first name contains 9 characters. So I'm going to assume that the maximum length of a name is going to be 9. You can think of changing that according to your program requirements. Eventually, we'll be learning how to get input from the user So you can potentially get that particular value as a user input. For now, I'm going to assume that maximum characters in a name is going to be 9. So you have the number of characters in a particular name which is given by len of that variable name. Then you have 9, which is going to be the max number of characters. So if you want to pad additional spaces after a particular player's name, you'll have to subtract len of that particular player name from 9, correct? So that's what I'm going to do here. So in order to add number of spaces, I need to first of all concatenate space before I display the score. And then after that, I'm going to multiply the number of spaces by 9 minus length of that particular player name to make sure that I do sufficient padding here. And I'm going to repeat this particular line of code for player number 2 as well. So let me get rid of this last line here. So something is off here. Okay, this is exactly what I was talking about when it comes to pasting code. You need to always make sure to fix the variable name. All right, looks like we now have padded the name of the player with additional white spaces and that we can read the result here very easily. Clearly, Bob is winning here. I'll wrap up this lecture video here. In the next video, we'll learn about rules for naming variables.